Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help these students who are preparing for CSIR, NEET, GATE, NEET-Jam, PhD-Jam, Statistical, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the lecture number 2 of atomic and molecular physics. Okay, and also guys, I would request these students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay. So let's get started. So this is the Sunday special class, guys. Okay, first class was already taken. That was of more than 2 hours. Okay, in last Sunday. So today I'm going to take second class, and this class is also going to be of more than 2 hours. Okay. Okay, guys. So let's get started. So last time we are solving questions. So the next question is, I'm continuing the questions. Okay. So question is, R infinity is given, that is equal to R1. Okay? R infinity is R1, and that we know that is for nuclear mass, which is infinite, right? For infinite nuclear mass, there is a Rydberg constant which is R infinity. Okay, for infinite. So R infinity equal to R1, that is nuclear mass for infinite nuclear mass. Okay. Okay, and if the nucleus mass to be 7500 times the mass of electron, then Rydberg constant R. Okay, so Rydberg constant is R. Okay, then Rydberg constant, this Rydberg constant R. Okay, and we need to find R2 upon R1 ratio. Okay, or we can say R infinite, R upon R infinite. Okay. So question is, R infinity is given, R infinity equal to R1 given. Okay, that is the nuclear mass. That R infinity is for the nuclear mass for infinite nuclear mass. Okay, for infinite nuclear mass. Okay, the nuclear mass is infinite. If the nucleus mass to be if the nuclear mass to be 7500 times the mass of nuclear electron. Okay, so there is a nucleus whose mass is 7500 times of the electron, then the Rydberg constant R, that is R2 upon R1 we need to find. Okay, Rydberg constant R. Okay, this one. Okay guys, so options are given. Option A, a little less than unity, a little less than unity, a little less than unity. Option B is a little more than unity. A little more than unity. A more than little more than unity. Little more than unity. Option C is infinitely small. Infinitely small. Infinitely small. And option D is infinitely large. Infinitely large. Okay. So this one. Okay, so nuclear mass to be, or nuclear mass is 7500 times the mass of electron. Okay, then Rydberg constant, and Rydberg constant is R given, and then R2 upon R1. Rydberg constant R. Okay, that is equal to R. We need to find R2 upon R1. Okay, so this is the question. I'm going to solve it. Okay, so this is, since we have guys, so we know that R is proportional to mu, right? And R infinite is proportional to ME. Okay, this we know. So from here we can get R upon R infinity. Okay, R upon R infinity is this one. R1 upon R2. Okay, sorry, R upon R infinity is R2 upon R1. Okay, so R upon R infinity from this we can get R upon R infinity. We can say this is equation 1 and this is equation 2. Okay, so R upon R infinity is going to be mu upon M. M is the mass of electron. Okay, so now what we are going to do is we'll find mu first. Okay, so mu is going to be this equation is third. Okay, so mu is going to be we know that mu is this one. M, that MP into ME upon MP, or we can say mass of nucleus. Okay, Mn into ME, right? So mass of nucleus is given 7500 times of mass of electron, right? Into mass of electron upon 7500 times of mass of electron plus mass of electron, right? So this value is going to be, this mu value is going to be this one. MME will get cancelled, so 7500 ME upon 7501 and 01, right? 7501. Right, this is the value of mu. This is the value of mu. Okay, so from here, now we'll put the value of mu in equation third. So R upon R infinity, or we can say R2 upon R1, because R1 is R infinity given and R2 is R given, right? So that is going to be, we'll put the value, this value, 7500 ME, 7500 ME upon 7501, okay, upon ME, right? Because this is the one. Me, mu upon me, mu is this, mu upon me. So me will get cancelled. So this value is going to be 7500 upon 7501. Right? So this value is going to be, so if we this value, get this, if we calculate this, this value is going to be, that is less equal to 1, right? Less equal to 1. Less equal to 1. Okay, because this is greater value, right? Less equal to 1, or this value is almost 0.99. Okay, so this is less equal to 1, right? So from here we can say, so we can write R2 upon R1 less equal to 1. Okay, and that implies R2 is less than R1. R2 is less than R1. So that implies less than R1, right? Yeah. So from here we can say that that E2 is less than E1. Okay, so E2 is less than E1. So you can see this, we can say, but here you can see, so this ratio is 1, right? This ratio is, we can see, little less than. This is the different thing. Okay, this is the formula, but according to the question, we can say this ratio is less than 1, right? So which option is matching? Option A is matching. That is a little less than unity. Of course, it is little less than unity, because if you calculate it, this value is going to be almost equal to 0.99, right? So this is little less than 1. So R1, R2 upon R1 is little less than 1. So that's what it is. That what is asked, right? So little less than unity. So option A is the correct answer. Okay. This one. Next question, guys. Next question I'm going to solve. Next question. This is the question 2, and this is asked in Jest 2013. Okay, this is the question. Just 2013 question it is. Okay, so it's a good question. I'm going to write it. So question is, if a proton if a proton were 10 times lighter, if proton were 10 times lighter than, if a proton were 10 times lighter, 10 times lighter than the okay, if the proton were 10 times lighter, okay, then proton were 10 times lighter than that mass of electron. Okay, sorry, 10 times lighter than mass of proton. Okay, actual mass of proton, it is 10 times lighter. Okay, then ground state energy of ground state energy of ground state energy of electron in H atom would be, in hydrogen atom would be. Okay, hydrogen atom would be. Options are given. Option A, less. Option B, more. Option C, same. And option D, that is can't be predicted. Can't be predicted. Okay, so this is the question. Very good question. So question is, a proton if a proton were 10 times lighter, then ground state energy of electron in hydrogen atom would be. So then we need to find ground state energy. Okay, if proton were 10 times lighter. Okay, so this would be less, more, same. Okay, or can't be predicted. So these are the options. I'll solve it now. So it is a just question, right? 2013 it was asked. Okay. So we know, guys, here this is, I have told you, E proportional to mu, right? This I have already explained, E proportional to mu. So, and we know mass of proton is 1836 times mass of electron. This is also we know, right? And m dash p, that is mass of proton, as per the question, is mp upon 10, right? 10 times lighter. 10 times lighter means 10 times lighter means mp upon 10. Okay, so this is going to be, we'll write mp value 1386 me upon 10, and this value is going to be 1836 me. It's mp upon 10 because it's 10 times lighter. Okay, 10 times lighter. If it would be 10 times heavier, then it will be mp into 10. Okay, 10 into mp. So now, so we'll find this one. Mu we know, right? Mu is mp into me upon, for hydrogen case. Okay, so it's a nucleus. Okay, and this is mp me, and we know the value. Mp value is 1836 me into me. Okay, upon, this is 183.6 me plus m. Okay, so me will get cancelled. Okay, so this is going to be 183.6 me upon 184.6 me, right? One is added, just 180. I mean, me is cancelled, right? So 184.6. Okay, and so from here, this is the value of mu, right? So now, or we can write, because this is this value, right? Or we can write mu upon me, because this me will, this is mu, right? Me will come in the denominator of mu, right? So me, mu upon me is going to be 183.6 upon 184.6, right? So if we solve it, this value is going to be 0.99. Okay. Okay, so now this is the ground state of hydrogen atom. Proton is 10 times lighter, right? So since we know E1, ground state of hydrogen atom, if when proton mass is normal, and that time we know that is minus 13.6 electron volt, right? And so this one, right? And also we know, since this one, okay, so now we know that E2 is proportional to mu, right? Is proportional to mu, and also for hydrogen atom, E1 is proportional to me, right? This is what we know. Okay, so so now we can write E2 upon E1, that is going to be mu upon me, and mu upon me value is this 0.99. Okay, this one, because this is this proportionality constant, you know. So E2 proportional to mu and E1 proportional to Me, right, for hydrogen atom. Okay. So from here we can write E2 value. The value of E2 is going to be E1 into E1 into 0.99. 0.99. So E1 value we know that is the actual ground state of hydrogen atom, that is minus 13.6 into 0.99. If we solve it, so this value is going to be uh, minus 13.52 electron volt, right? 13.52 electron volt means E2 is greater than E1, right? E2 is greater than E1, right? Because the E1 value is 13.6 and this is minus 13.52. It is minus 13.6, it's minus 13.52, right? It is in negative, so less value will be higher. So E2 is greater than uh, E2 is greater than E1, right? So E2 is greater than E1. Okay. So which option is matching, guys? So for this, more. So according to question, it is asked, proton were 10 times lighter, then ground state of hydrogen atom would be less, right? So less is the correct, because you can see E2 is less than this, right? So grounds E2 is less than, E2 is greater than this. E2 is greater than, so it should be greater. E2 is greater than this. So ground state energy will be more, guys. Okay, so more is the correct option. Okay, next question. Okay, next question which is asked in TIFR. Okay, TIFR. So there is one more question like this one. This is I'm going to solve. So there is question which is asked in Jest first. Okay, Jest 2014. Just 2014. So here given if MP dash, okay, MP dash, that mass of proton is 10 times heavier, okay, 10 MP. In that case, I'm writing directly, okay. So in that case, mu value is going to be 10 into MP into Me upon Me plus 10 MP. And now we know MP is 1836 times Me. We'll put the value, so mu is going to be this one, 10 into 183, 6 into Me upon, this is going to be uh, this one, 1836 1, okay, 1836 plus 10 Me will get cancelled, okay. So mu value is going to be this one, this is 10 times, right? This is 10 times, so this one, 10 MP, okay, and this is ME. So this is going to be 60 and 60, right? So this value is going to be 1836.0 upon 1836.1, okay, and this value and into ME, okay, ME, because 1 ME is ME. So from here, so value of mu upon ME, that is going to be 0.9. So again, this E2 is proportional to mu, and E1 for ground state hydrogen atom, E1 is proportional to ME for infinite nuclear mass, right? So this implies E2 upon E1, that is going to be mu upon ME, and this value is 0.9. Okay, so from here E2 is also going to be 0.99 into E1, and this is 0.99 into E1 value, we know, minus 1360, right? Electron volt, and so this value is going to be again same 13.52. So in this case also E2, the minus, right? Minus, less value in minus is greater, right? So E2 is greater than E1. E2 is greater than E1. So again, this one, the energy will be greater, okay, more. So this is the question. Now I'm going to solve TIFR question, okay? TIFR question. Question which is asked in TIFR. The question is, for a hydrogen atom, for a hydrogen atom, velocity of electron velocity of electron in nth orbit, in nth orbit is Vh, okay? So for hydrogen atom, the velocity of electron in nth orbit is Vh. For a positonium, positonium means it is made of electron and positron, okay? Electron is moving around the positron, okay? So for a positron, it is Vp, then options are Vp, that velocity, that is the velocity of electron, okay? Nth orbit is Vh, and for positron, it is the velocity of electron is Vp, okay? So options are Vp equal to 2Vh. Option B is Vh equal to 2Vp, okay, and option C is Vh equal to Vp, and option D is Vh equal to 3Vp, okay? So positron means positron is like this. There is a positonium means there is a positron, okay, and electron is moving around it, okay? So it's electron positron system, okay, that is positonium, okay? So in question we have been given the velocity of For a hydrogen atom, velocity of electron in nth orbit. For nth orbit, for hydrogen atom, the velocity of electron is Vh given, and for positonium, the velocity of electron is for nth orbit is Vp. That is given. Now we need to find which relation is correct. Okay. Okay. I'll solve now. Now we know there's a formula, right? We know velocity. We know velocity is proportional to V is proportional to Z upon N. I have already explained Z upon N. Okay, in my previous lecture. So velocity is proportional to Z upon N, right? So this is atomic number upon the orbit. Okay, N is the number of orbit, right? And so we can see which is independent of mass, means which is independent of mass. You can see velocity is proportional to Z upon N, and we can see it depends on atomic number and the orbit, right? And there is no mass, means which is independent of mass. Independent of mass means that implies Vh equal to Vp. So velocity of electron in hydrogen atom is in nth orbit is going to be equal to velocity of positonium, velocity of electron in positonium in nth orbit. Okay, because velocity is independent of mass. So Vh equal to Vp. So this is the answer, guys. Okay. Next question. So this question is asked in TIFR. Okay. Very simple question. Okay. Next Sommerfeld theory. Okay. I'm going to discuss. Sommerfeld theory. Okay. So in Sommerfeld theory, which is given by Sommerfeld, so all electrons, according to it, all electrons move around the all electrons move around the nucleus. All electrons move around the nucleus in an elliptical orbit. In both, we have seen that electron moves in circular orbit, right? So, according to Sommerfeld, all electrons move around the nucleus in an elliptical orbit. Okay, elliptical orbit, and circular orbit. Circular orbit is one of the special case. Okay, one of the special case. Okay, so according to Sommerfeld, all electrons move around the nucleus in elliptical path, guys. Okay, and circular orbit is one of the special case. Okay, like this. I'll show you. Okay, so this is the elliptical orbit. Okay, so electron moving elliptical orbit, and circular orbit is one of the special case. Okay, and there is a k. K is azimuthal quantum number. Okay, if Sommerfeld introduced it. So azimuthal quantum number. Azimuthal quantum number. Okay, K is the azimuthal quantum number. Okay, and this is very important case. N upon K is greater than 1. N upon K is greater than 1, or we can say N is greater than equal to 1. N is greater than equal to K. Okay, so okay, this one. N is greater than N is principal quantum number, right? So N is greater than equal to K. Very important one. This one. N is greater than equal to K. Okay. So where K values are 1, 2, K values are 1, 2, 3, so on. Okay. Okay. So now we'll study different cases like case 1. Talk about case 1. Case 1, that is N equal to 1. Okay, N equal to 1 implies K equal to 1. Okay, so N, because K values are this, K is greater than N is greater than K. So if N equal to 1, so K will be 1 because K starts with 1, 2. Okay, so K equal to 1. So in that case, N upon K is going to be equal to K upon B. So this is the elliptical path, guys. This is elliptical path. Okay. This is major axis, and this is minor axis. Okay, minor axis. This is B. So N upon K is A upon B. Major axis upon minor axis. Well, this distance and this distance. Okay. So N upon K is K equal to this, and N upon K value we know that N equal to K equal to 1. 1 upon that is A upon B. So in that case, A equal to B. If N equal to 1, K equal to 1, then the orbit is going to be circular. So this is A equal to B means implies this is going to be circular orbit. Circular orbit. Okay. Case 2. Case 2. Case 2 is N equal to 2 and K equal to 1. So for N equal to 2 and K equal to 1, because N is greater than K, right? Greater than equal to K. So K equal to 1 or N equal to 2. So in that case, N upon K value is going to be 2 upon 1, or that is equal to A upon B, because N upon K value is A upon B. This is the formula, N upon K equal to A upon B. Okay, so here I can write A upon B, that 2 upon 1. So in that case, A is going to be equal to 2B. A is 2B. Okay, and next part is if N equal to 2, N equal to 2 and K equal to 2, N equal to 2 and K equal to 2, K equal to 2. So in that case, N upon K, that is A upon B, right? So N upon K is going to be this one. 2 upon 2 is going to be A upon B. That implies A equal to B. Okay. So then this is going to be this ellipse. In that case, this one, this ellipse This ellipse is going to be circle. Okay? Like this. And this is circle, this is ellipse, guys. It is not looking, but consider this is circle, this is ellipse. Okay. Okay. So K depends. This K the K. Okay. Now energy depends on K, azimuthal quantum number. Okay. And K represents subshells. Okay. Subshells. K represents subshells. Those are like S, P, D, F, and so on. Okay. So that these subshells are represented by K, and all subshell will have all subshell all subshells all subshells all subshells will have different energies. Okay, different energies. So transition energy. So transition energy also depends on subshells energy. Okay, subshells subshells energy subshells energies. Okay, so this is the Sommerfeld theory. Okay, now guys, I'm going to solve question. Okay, this is also a good question, guys, and this is asked in CSIR net June. So question is first it is asked in this one, CSIR net CSIR net CSIR net June 2018. Meanwhile, just let me check whether I'm audible or not. I'll proceed first. Will have, yes, I'm audible. I'll proceed further. Okay. Okay. So question is, so CSIR net June 2018 it was asked. Okay. The question is a photon of energy a photon of energy A photon of energy 11.62 kilo electron volt keV ionizes a photon of energy 11.62 kilo electron volt ionizes a K shell electron, a K shell electron, K shell electron, K shell electron of beryllium atom. Okay, beryllium atom. One L shell electron, one L shell, one L shell electron, one L shell electron jumps, one L shell electron jumps to K shell, jumps to K shell to fill this vacancy, to fill this vacancy, to fill these vacancies and emits photon, emits photon, emits photon of energy, photons of energy 109.2 kilo electron volt in the process. Okay, in the process, in the process, if the ionization potential, if the ionization if the ionization potential, if the ionization potential of L shell is 6.4 keV, 6.4 keV, then kinetic energy of Be beryllium, kinetic energy of beryllium, kinetic energy of beryllium ionized electron, beryllium ionized electron is, okay, so options are, option A is 20 kilo electron volt, 20 kilo electron volt, option B is 20 electron volt, option C is 0.223 electron volt, and option D is 40 electron volt. Sorry, this is 40 kilovolt. Okay, 40 kilovolt. Okay, guys, I'll solve it. Just give me 1 second, guys. Okay. Okay, guys. So I'm going to explain the question first. Question is very good question, guys. A photon of energy 11.6. Sorry, this is 115, guys. 115. So 100 a photon of energy 115.62 kilo electron volt. Okay, that energy photon ionizes a K-shell electron of beryllium atom. So this energy photon is ionizing the K-shell electron of beryllium atom. Okay, one L shell electron jumps to K shell. Okay, so one L shell electron jumps to K shell. Okay, to fill the to fill this vacancy. So that is that K shell electron is ionized. Okay, and goes to an infinity level. Okay, n equal to infinity level. Okay, so L shell electron jumps to K shell to fill the vacancy and emits a photon of energy 109.2 kilo electron volt. Okay, this energy is emitted by that in the process. Okay, if the ionization potential of L shell is 6.4 kilo electron volt. Okay, so ionization energy ionization energy of L shell is 6.4 electron volt 6.4 kilo electron volt. Okay, then kinetic energy of beryllium ionized electron or kinetic energy of electron, that ionized electron, that's what we need to find. Okay, very simple question. So since we have given the energy of photon. Okay, energy of photon, we have given energy of photon, and that is 115.62 electron volt. Okay, so this is 115.62 electron volt, that is the energy given. Okay, so ionization energy is given. Okay, ionization energy, ionization energy, this is very important point, right? Ionization energy is going to be that this this one L shell electron jumps into K shell to fill the vacancy and emits a photon of energy. This photon energy. Okay, because this is the photon energy because of that L shell electron and the ionization potential of L shell. Okay, this is important. So this is going to be 115 point. Sorry. So this is going to be, my apologies. So this is going to be this one. Energy of energy emitted by photon. Okay, energy of L electron. Okay, which fills the vacancy and the and emits the energy, right? This one emits photon of energy. So this one, so L shell electron jumps to K shell to fill this vacancy and emits a photon of energy, this. Okay, so photon of energy, this. So the emitted the photon of emitted photon, energy of emitted photon, that is 109.62. Okay, this is the emitted energy of emitted photon due to jump of L cell electron into K shell plus ionization potential of L shell, this one. Okay, ionization potential of L cell is this. Ionization potential of L shell is this, right? So this is going to be this one, 6.4, and this is this one, right? So kilo electron volt. So this value is going to be 115.60 kilo electron volt. Okay, and so this implies that Ke of ionized electron or beryllium ionized electron, Ke of beryllium, Be, right? This is Be ionized atom, Be ionized electron, Be ionized electron, Be ionized electron, that is going to be 115, this energy 115.62 minus 115.60, that is going to be this one, 0.02 kilo electron volt, right? And this value is going to be 0.02 kilo electron volt, right? And we can convert this. So this kinetic energy is going to be this one. 0.02 kilo electron volt means this one 0.0 0.02 into 10 to the power 3 electron volt, right? So this is going to be 20 electron volt. Okay, this is the answer, guys. So I'll explain here like this. Okay, so this is the uh, this is proton, guys. Okay, this is the nucleus, and these are the shell of the this one, that beryllium atom. Okay, this is K. This is so this is K shell. Okay, this is K shell and this is L shell. You need to understand. So the ionization energy for this is given. Okay, so ionization energy we need to find out. Okay, this one, the the kinetic energy of ionized electron. Okay, this we need to find. So ionization energy. So we have given this 115.62 kilo electron volt energy we have given. One electron from K shell, this is K shell. Okay, one electron from K shell, this electron ionized, right? And L shell electron, this L shell electron jumps into here, right? L shell electron and emits the photon of energy. This is given 109.2. Okay, kilo electron. And ionization potential of this shell is given, that is 6.4 kilo electron. Ionization potential of this shell means the ionization energy of this shell, right? The energy required to remove the electron from this shell completely, right? So this is the condition, guys, right? So we have been given the energy for this electron. Okay, energy is given, that is 115.62 electron. So now first we will find ionization energy. Ionization energy of this shell is going to be the because electron jumps here, right? The photon emitted by electron which jumps from L shell, this plus ionization potential or ionization energy of L shell. This plus this is going to be the ionization energy of this, guys. Ionization energy of this shell. So ionization energy of K shell is going to be photon emitted by L electron when it jumps from L to K plus the ionization energy of this L shell, right? So that's why this energy, so energy of photon or this one, energy of so ionization energy is going to be the the energy emitted or the photon emitted by the L shell electron when it jumps from L shell to K shell plus ionization energy of the L shell. Okay, so this is the ionization energy we've got. Now kinetic energy is total energy given minus ionization energy, right? That is 2 electrons. I hope, guys, you have understood it. It's a good question, and this question is asked in CSIR net June 2018. Okay, okay, guys. So this is the one. Next, we are going to study, that is quantum number. Okay, quantum number. Quantum number. So, I will study quantum number. Okay, so we know the quantum number, that is principal quantum number, orbital quantum number, orbital magnetic quantum number, spin quantum number. Okay, basic thing, and then we'll start with basic things. Okay, so this is first is principal quantum number. Principal quantum number. Principal quantum number. Principal quantum number. Okay, so this is represented by n, right? N. So it represents shells. Okay, it it represents shells. Okay, so principal quantum number, that is n. This represents shells. Okay, so that is n equal to 1, 2, 3, so on. Okay, so 1 denotes that n equal to 1 means k shell, n equal to 2 means n equal to 2 means l shell. Okay, and n equal to 3 means m, then 4 means n. These are the shell. Okay, so n represents shells. Okay, n values are 1, 2, 1, 2, 3, so on. Okay, integer. Second is orbital quantum number. Orbital quantum number. Orbital quantum number. Okay, orbital quantum number, it represents subshell. Okay, so represents sub, I am writing as a point. Okay, so I'm writing this main points. Okay, so this is represents subshells. Okay, quantum number represents subshells. Represents subshells. Okay, so these are like 0, 1. This is represented by L. Okay, L equal to 0, 1, 2, 3, so on. So 0 means S, and P. Okay, orbital quantum number is represented by L, guys. Okay, L values are 0, 1, 2, 3. So 0 means S, 1 means P, 2 means D. Okay, 2 means D, and very basic things, guys. And 3 means F, and so on. Okay, so this is the orbital quantum number represented by L. Okay, next is orbital magnetic quantum number. Okay, orbital magnetic quantum number. Orbital magnetic quantum number. Orbital quantum number is L, and orbital magnetic quantum number is denoted by ml. Okay, so states. So this is states corresponding to states corresponding to the subshells. Okay, so orbital magnetic quantum number, that is states. These are states corresponding to subshells. Okay, subshells. And so I'll give example. So this implies for L equal to 0, implies value of ml are going to be 0, and for P equal to so this is the P, right? L equal to 0 means S. For L equal to 1, this represents P, right? L equal to 1 means P. L equal to 1 means P. So this implies ML values are -1, 0 and 1. Okay, similarly, if we talk about L equal to 2, that is D, right? L equal to 2 implies values of ML are going to be -2, -1, 0, 1 and 2. Okay, okay. So, possible values of ML are going to be by formula. The possible values that is going to be possible values, that is 2L plus 1. Okay, like for L equal to 1, 2L plus 1, that is 1, 2, 3, right? 2 into 1 plus 1, 3. L equal to 2, 2L plus 1. 2 into 2, 4 plus 1, 5, right? 1, 2, 3, 4, 5. So these are the possible values of ML, right? So for L equal to 0, ML value are 0. L equal to 1, ML value, there are 3 values of ML. For L equal to, there are 5 values of ML, right? So this is orbital magnetic quantum number, ML. Very simple thing. Very simple thing which we have already studied in class 11, 12. Okay. Next is this is orbital magnetic, right? Next is spin quantum number. Okay, spin quantum number. Spin quantum number. Spin quantum number. Okay, spin quantum number, and that is denoted by S. So for electron, if we talk about electron, the value of S is spin quantum number is half. Okay. Now magnetic spin quantum number. Magnetic spin quantum number. So magnetic spin quantum number. Okay, magnetic spin quantum number. Magnetic spin quantum number means it represents orientation of electron, orientation of electrons, in the state. Okay, in this state. Okay, so it represents orientation of electron in this state. Okay, orientation of electron in this state. So ms equal to minus s2 plus s. Okay, these are the values. So ms value for s equal to 1 is going to be minus s2 plus s, right? So since s equal to half, so ms values are going to be minus s2 plus s, right? So this is minus half and plus half. Okay, so these are ms values. Okay, next is orbital angular momentum. Okay, orbital angular momentum. Orbital angular momentum. Okay, that is L. Very important, guys. Orbital angular momentum L. So this is due to motion of electron in orbit. Okay? Orbital angular momentum is due to motion of electron. This is due to motion of electron, due to motion of electron, due to motion of electron in an orbit, in an orbit. Okay, so it's so orbital angular momentum L is due to motion of electron in orbit. Okay, so electron is moving in the orbit, right? And because of that, there is a angular momentum L, and that value will find we will find. Okay, so we know value of L. Value of L is h cut root L into L plus 1. H cut root L into L plus 1. Okay, so this is the value of L. Okay. So this is the orbital angular momentum. I'll derive it for you later. Okay. Next is spin angular momentum. Spin angular momentum. Spin angular momentum. Okay. So due to spin of an electron, it is due to spin of an electron. Okay. Due to spin of an electron, and this is because of spin angular momentum. Okay, so value of S is h cut root S into S plus. Important result. Okay, next is total angular momentum. Total angular momentum. Total angular momentum. Total angular momentum. Okay, so total angular momentum is represented by J, and J is J equal to L plus S. That is the total angular momentum is sum of orbital angular momentum plus spin angular momentum. Okay, and this value J is going to be h cut root J into J plus 1. Okay, h cut root J into J plus 1, where J is inner quantum number. Okay, J is inner quantum. J is inner quantum number. Okay, okay. Next is orbital magnetic moment. Okay, orbital magnetic moment. Orbital magnetic moment. Orbital magnetic moment. Okay, orbital magnetic moment. So this is Orbital angular moment, orbital magnetic moment means the magnetic moment we know, right? Orbital magnetic moment is denoted by mu, right? So our orbital magnetic moment is denoted by mu l. Okay, so mu l value is I I I dot I a, right? I into a vector a. Okay, and here we'll explain like this. This one. So this is the orbit, okay, of radius s. Electron is moving, okay, and this is z z axis, okay, and along z axis, this is the direction of angular momentum, okay, direction of angular momentum, direction of angular momentum, and this is towards the down, okay. This is a negative in negative z axis. There is a mu l, that is a magnetic moment, orbital magnetic moment, okay. So electron is moving in this circular orbit, right? And along z-axis there is a angular momentum, and along minus z-axis there is a magnetic orbital magnetic moment, right? So now we can find the current I. I is this one, E upon T. T is the time, right? To completing one circle. Okay, so this is, and so from here I is going to be E upon is the charge on electron, right? Because we know I is Q upon T, right? Q is E. So E is electron, E upon T is, this is T value is 2 pi, 2 pi, that this circumference, that is 2 pi R, 2 pi R upon V, right? This is the time. So the velocity, or the electron is moving with velocity V in the circular orbit, right? So from there, the time completing one orbit, one round is going to be the total distance upon velocity, that is 2 pi r upon v, right? So I value is going to be, from here I value is going to be ev upon 2 pi r, ev upon 2 pi r, ev upon 2 pi r. Okay, now mu l is going to be, mu l is going to be this one. Mu l value is I into a, right? So I value we have got it, that is e upon 2 pi r, right? So this is going to be ev upon 2 pi r, ev upon 2 pi r into area. Area of the circle is pi r square, right? So pi r square. So from here, this is the mu l, and this is along minus z axis, right? So minus z axis, or mu l value is going to be this one. Pi will get cancelled, r will get cancelled. Ev r upon 2 pi, and this is minus z axis, right? And so now mu l is going to be, now what we can do is mu l is, we can multiply this by m and divide by this m, okay? This is going to be e mvr upon 2 pi m, e mvr upon 2 pi m, right? 2 pi m, and since we know value of angular momentum is this one, mvr, mvr, right? Mvr, this value is going to be mvr, this is minus z axis, right? mvr, and which is along z axis, this one along a positive z direction, right? So this value, that mu l value is going to be then, mu l value is going to be, mu l value is going to be, minus can write directly. So it is E upon L upon 2m. Okay, because this is in z direction, plus z direction. Okay, this is in plus z direction. So if you put this value here, so this value is going to be minus minus EL upon m, and then mu L vector upon L vector, the ratio of magnetic moment, orbital magnetic moment upon orbital angular momentum, that is going to be minus E upon 2m. This is very, very important formula, guys. Many questions you will get using related to this formula. Okay, so this is mu L upon L equal to minus E upon 2m. Okay, this is important formula, you need to note down. Okay, and minus sign represents minus sign represents minus sign represents mu L and angular momentum L are opposite to each other. Okay, are opposite to each other, meaning in direction. Okay, each other, opposite to each other. You can see here, because in figure you can see this is in negative z direction, this is in positive z direction. Okay, now we have, and if we take the mod of this, right, so mu L upon L mod of mu L upon L vector mod, this mod is going to be E upon m. If we take mod, okay, E upon 2m, E upon 2m. Okay, and this ratio is mu L upon L, mod of mu L upon L, this ratio is known as gyromagnetic ratio. Okay, important one. Gyromagnetic ratio. Gyromagnetic ratio. Okay, so now, so from here we can write mu L, mod of mu L is going to be E upon 2m, E upon 2m into L vector. Okay, mod of L, or we can write mu L, mod of mu L, E upon, and this value we know, right, this value is h cut into root L into L plus 1, right, this value we know. Okay, and this one, guys, this is very important. So since E upon h cut upon 2m is mu b, okay, mu b, this is Bohr magneton, guys, Bohr magneton, or mu b, or we can write E upon h is h cut is h upon 2 pi, right, or we can write this one, or equal to eh upon 4 pi, 4 pi m, 4 pi m. Okay, and this is Bohr magneton. Bohr mu b is Bohr magneton, guys, Bohr magneton. Bohr magneton. Okay, okay, now we can write this mu L value, mod of mu L is going to be mu b into root L into L plus 1. Okay, very important formula, you need to note down. Okay, so mod of mu L is mu b into L plus 1. Okay, mu b into L plus 1. Okay. Next is this is important one. Next is this mu L value of mu L okay, value of mu L is small. This is going to be equal to GL mu B and root L into L plus 1. Okay, this is the value. Here GL value is 1, guys. Okay, GL value is 1, and this is called orbital G factor. Orbital G factor. Okay, so this is called orbital G factor. Orbital G factor. Okay, so this is the formula, guys. Actually, mu L value where GL value is 1. That's why this value is mu L equal to mod of mu L equal to mu B into L plus 1. Okay, because GL value is 1, and actually this mod of mu L is GL mu B into root L into L plus 1. Okay. Okay. Next is this ratio. Okay, and you need to note down this point. The ratio mu L upon L ratio of mod mu L upon L that does not depend on doesn't depend on the size okay, that doesn't depend on the size or shape size or shape of the orbit shape of orbit or an orbital frequency or an orbital frequency. Okay, next is the magnetic moment in z direction. Okay, magnetic moment in z direction. Magnetic moment in z direction. Magnetic moment in z direction. Okay, so magnetic moment in z direction. So means magnetic moment in z direction means z component of magnetic moment. Okay, so that is z component of magnetic moment. Z component of magnetic moment. Z component of magnetic moment in Z component, and that formula is, that is mu L value is minus GL G factor, orbital G factor, right? Orbital G factor, GL mu B Bohr magneton mu B into root L into L plus 1. Okay, so mu L value is minus GL mu B root L into L plus 1. Root L into L plus 1. Okay, and so from here we can write mu Lz. Okay, so this is mu Lz, Z component, magnetic moment in Z direction. Okay, Z component of magnetic moment. Or we can write mu Lz equal to minus GL mu B. Okay, this is Lz upon H cut, we can write, right? Lz upon H cut, or L upon H cut means Lz upon L cut is, we are talking about Z component, Lz upon H cut, right? And here guys, this one, since we know L is H cut root L into L plus 1. So from here L root L into L plus 1 value is going to be L upon H cut. Okay, and also guys, you should know, I'm writing here, Lz value is ml H cut, ml H cut, and similarly this one Sz value is going to be ms H cut. Okay, and Jz value is going to be mj H cut. Okay, mj H cut, mj H cut. So these are the values. So now we can put this value, Lz value, in this equation, right? So this is mu L is going to be, or we can just leave it. Okay, so this is the important formula guys, you need to note down this one. Mu Lz, the Z component of magnetic moment, is minus GL mu V Lz upon H cut. Okay, Lz value is this one, ml H cut, Sz value is ms H cut, Jz value is mj H cut. Okay, important one. Next is space quantization. Okay, space quantization. Space quantization. So space quantization I'm going to discuss. Space quantization is the quantization of one component of one component of angular momentum, L or S. Okay, so quantization of one component of angular momentum L or S in any direction. Okay, in any direction. Now here, this is magnetic field, B this is L, this is L. Okay, so this is so this is we are studying we are going to study this space quantization. Okay, so quantization of any component of angular momentum or s in any direction. Okay, so this is the L vector angular momentum. Okay, so we'll get the L, the z component. Okay, so this is the component of L along the direction of B. Okay, and this is the B is in the direction of Z. Okay, okay, so here we know guys that is angular momentum L, Lz equal to this Lz along Z direction. Okay, Z along Z direction. Along Z direction there is B vector as well. Okay, magnetic field direction is also along Z direction, and now we need to, so we will find this L component along Z direction. Lz is going to be L, this is L. Okay, mod of L vector, mod of L vector cos theta. Okay, since Lz equal to ml h cut, right? This we know. So from here we can write cos theta equal to ml. I'll solve question, then it is going to be more clear. Okay, so ml h cut upon h cut root L into L plus 1 cos theta, because this is ml h cut and this value is h into root L into L plus 1. We'll solve it further. So cos theta is going to be h cut will get cancelled. Okay, so ml upon root L into L plus 1. Okay, this is an important formula. Okay, cos theta equal ml upon L into L plus 1. Okay, so we know, sir, for L equal to 1, ml values are going to be -1, 0, comma 1. Okay, this one. Okay guys, just give me 1 minute and then I'll start. Okay, okay guys, so now cos theta equal to ml upon root L into L plus 1, right? So here you need to understand, because if for L equal to 1, the value of root L into L plus 1, root L into L plus 1 means 1 into 1 plus 1. That value is going to be 2, root 2, right? And this value is 1.414, right? So since root L into L plus 1 for L equal to 1, right? Greater equal to ml. So this value is 1.44 and L values are 1, right? and ml values are this. So obviously this is great. So this value is greater than ml. Okay. So it means very important. Cos theta value is going to be always less than 1. Okay. That implies theta value is not equal to 0 or pi. Okay. So this cos theta is this. So this value is less value and this is greater value. So this value is always the cos theta value is always coming less than 1. Less than 1 means the theta values will never be 0 or pi. This will be between 0 and pi, right? So we can write it. That implies L can never, this L, orbital angular momentum, L can never, L can never L can never be aligned. L can never be aligned, parallel, aligned. L can never be aligned, parallel or anti-parallel, anti-parallel, anti-parallel. Okay, so L can never be aligned, parallel or anti-parallel. Right? Here you can see this one because this values this L value cannot cos theta value cannot be 0 or minus pi, right? So L will this L can never align parallel or anti-parallel. Okay, because that value is always cos theta value is always less than 1. Right? So L can never be aligned parallel or anti-parallel to B. This is important. Okay. Next is this cos theta. Cos theta for values Lz upon L. Lz upon L, or we can write ml upon root L into L plus 1. Okay. And cos theta value is going to be for spin Sz upon S. Okay. So this value is going to be ms into root S into S plus 1. Okay. And similarly, this will tell the orientation. Okay. And cos theta value is going to be Jz upon J, Jz upon Jz upon J, that is Mj upon root J into J plus 1. J into J plus 1. Okay, this is the value. So orientation for this is 2l plus 1. For this 2s plus 1. And for this 2j plus 1. 2j plus 1. Okay. So 2j plus 1. These are all possible orientation. Okay. So for this 12 plus 1, for 2s plus 1 for this, and for this 2j plus 1. Okay. Next I'm going to solve question. Okay. Question is calculate possible orientation. Calculate possible orientation calculate possible orientation, calculate possible orientation of J, for possible orientation of J corresponding to J equal to 3 by 2 with respect to magnetic field, along Z-axis. Okay, this is the question. Calculate possible orientation of J. So we have to find the possible orientation of J corresponding to J value given 3 by 2 with respect to magnetic field along Z direction. Okay, magnetic field along Z direction. Okay, so we have been given like this. So this is Z direction. Okay, and magnetic field direction is also same. And this is L. This is L, and this value is theta. Okay, this is L, this value is theta. So you need to find this. We need to find possible orientation. Okay, so from here we know that LZ, this is L. Okay, possible orientation of J we need to find. Okay, J means this is J, guys. This is J. This is theta. So J, so from here the JZ is going to be J cos theta or J cos theta, right? Or from here cos theta value is going to be Jz upon mod of J. Okay, so cos theta value is going to be mg h cut upon h cut J value of this Jz value we have put, and this mod of J value h cut root J into J plus 1. Okay, so this value is going to be h cut will get cancelled. So mj upon root J into J plus 1. Okay, mj equal to root J into J plus 1. That is cos theta. Okay, now we'll find possible orientation. So this is going to be since J is given, that is 3 by 2. Okay, so possible orientation formula we know that possible orientation this one, possible orientation. Okay? Possible orientation. So this is, we know that is for J is 2J plus 1. So this is going to be 2 into 3 by 2 plus 1. That is 4. So there are 4 possible orientations. Okay, we'll find one by one. Okay, so mj value, where J value is this, so mj value is going to be mj value we know, right, minus J2 plus J, right? So this is minus 3 by 2 comma minus 1 by 2 comma 1 by 2 comma 3 by 2. Okay, so these values are going to be We will find cos theta 1. Cos theta 1 value is going to be this one. Simple, this formula, right? Mj into j into j plus 1. Mj is 3 by 2, we can put. So mj upon root j into j plus 1. So mj possible values are this minus 3 by 2, minus 3 by 2, and this value is going to be this one, root 3 by 2 into 3 by 2 plus 1. Okay, so if you solve it, this value is going to be minus 3 by 2 upon root 15 by 2. So 15 by 2. 2 will get cancelled, and this value is going to be minus 3 upon root 15. Minus 3 upon root 15. Okay. So cos theta 1 value is minus 3 upon root 15. This implies cos theta 1 value is going to be 140 degree. Okay. So similarly, cos theta 2 value is going to be, theta 2 is this one, minus 152, and then value is half into root 15 upon 2. Okay. So this means this is going to be minus 1 by 15 root 15, right? That implies theta 2 value is going to be 104. 140, 104. Now cos theta 3. Cos theta 3. Cos theta 3 value is going to be simple, that 1 by 2, and then value is 1 by 2 upon root 15 by 2. That is 1 upon root 15, right? And this value is, this implies theta 3 value is going to be 75 degree. Similarly, cos theta 4. This is 3 by 2 upon root 15 by 2. So 2 will get cancelled. So this is 3 by root 15. Okay. And that implies theta 4 value is going to be 39 degree. Okay. So 39, 75, 105, and 140, right? So these are the possible orientation, and we can represent it here like this. So this is minus 3 by 2 h cut. This is 1 by 2 h cut. This is 0. This is 1 by 2 h cut and 3 by 2 h cut. Because ml values are this, right? And lz value is going to be mh cut, right? So that's right. And now this angle like this is 0, right? The first angle is for this one, 39 angle. This is 39 degree for ms value 3 by 2. Second is 75 degree. This one, 75. This complete one. Okay. 75 degree for ms equal to 1 by 2. And then this is going to be like this. This complete value is going to be 104 degree for ms equal to half, ms equal to minus half, and this value, this complete angle is 140 degree, and this value is for ms equal to minus 3 by 2, right? If you join it, it is going to be like this. Okay, like this. This is the orientation. Okay, so these are the angle and these are orientation. This is like parabolic. Okay, like this. Like this. This is like this. Okay. Okay. So this is the orientation. Next question I'm going to solve. Next question is s equal to half. S equal to half given, and space that is, and you need to find space quantization. Space quantization. Space quantization. Okay. Space quantization. So we know for cos theta is going to be, I'm writing directly for s, ms equal to root s into s plus 1. Okay, so and possible value as well is given. So possible values ms is going to be 2s plus 1, right? So this is 2 into half plus 1, that is 2. Okay, so ms values are going to be s is half, ms values are minus half, comma half. Okay, so now we'll find cos theta 1. Cos theta 1 is going to be simple, minus 1 by 2 root 1 by 2 into 1 by 2 plus 1. Okay, this one, and this value is going to be minus 1 by 2 upon root 3 by 2, and this value is going to be minus 1 upon root 3. Minus 1 upon root 3, this is the cos theta 1. Cos theta 2 value is going to be cos theta 2, this value is going to be 1 upon 2 because ms value is this, and upon root 3 by 2, because this value we have already found, right? 2 3 by 2, and this is 2 2 will get cancelled. So this is 1 by 3, so implies theta 2 value is going to be 54 degree. This is 54 degree, and this is here theta 1 we have find. Theta 1 value is 125. 125. Okay, so these are the values of theta 1 and theta 2. Right, so we can now make a figure for space quantization like this. Okay, so the first value, this one, okay, so this is minus half mh cut, and this is plus half mh cut, right? So the first angle, that is theta 2, 54 angle is like this. 54 angle for ms equal to half, and now this another one is 125 angle. 125 angle, this is 125 for ms equal to minus half. Okay, so we can join this like this. Like this. Okay, so this is the space quantization, and this is the figure. Okay, I hope guys you have understood it. Okay, next is spin magnetic moment. Okay, spin magnetic moment. Next is spin magnetic moment. Spin magnetic moment. Spin magnetic moment. Okay. Spin magnetic moment is mu s equal to gs mu b root s into s plus 1. Like for angular orbital magnetic moment, it was mu l equal to gl mu b l into root l into l plus 1. Similarly, mu s is spin angular momentum and spin angular moment. Mu s is gs mu b root s into s plus 1. Okay, where gs equal to gyromagnetic ratio, gyromagnetic ratio of electron spin. Okay, and the value of gs equal to 2. Okay, and this is why 2, due to two orientation, due to two orientation due to two orientation. Okay, so s value is half. So since s value is half, so the mu s value is going to be, if you put this value, 2 into mu b root s into s is half, right? So half into half plus 1, half into half plus 1. So if you calculate this value is going to be, mu s value is going to be root 3 mu b, root 3 mu b. Okay, so this question is asked, mu s equal to root 3 mu b. This question is asked in gate and Jest. Gate and Jest. Gate and Jest. Okay, so mu s equal to root 3 mu b. Okay, mu s equal to root 3 mu b. So this question is asked. Okay, gate and Jest. Next. Next is vector model of atom. Okay, vector model of an atom. Vector model of an atom. Okay, so this is J equal to L plus S. Okay, this is the vector model, and total angular momentum is sum of orbital angular momentum and spin angular momentum. So I'll show you by figure this one. Okay, so this is the one. This value is L. Okay, S vector, and here this is S. Okay, this is S vector and this is L, and this is J vector. This is J vector. Okay, this is J vector. So this is J vector. So the L vector spins and S vector also spins. Okay, around here. So here J equal to L plus S, right? That implies in this case uh, J is greater than S, greater than L, right? And also J equal to L minus S implies J is mod of J less than L, mod of L, less than mod of L. Okay. So here we have vector model we are studying. Okay. So here we have J equal to J equal to J equal to L plus S, L plus S. We can write J dot J, that is going to be L plus S into L plus S. Okay, dot. And so from here, this mod of J square, mod square of J, that is going to be mod of L square plus mod of S square, mod square of S plus 2 mod of L mod of L into mod of S cos L dot S. Okay, so from here cos L dot S, this value is going to be mod of J square minus mod square of L minus mod square of S upon 2 into L into S. Okay, so this value is going to be cos theta cos L dot S. Cos L dot S is going to be J into J plus 1. We are just putting the value. Okay, this value is h cut square root h cut square into J plus 1. Okay, h cut here also h cut square will get J into J plus 1 minus L into L plus 1 minus S into S plus 1 upon 2 into uh, root L into L plus 1 into root S into S plus 1. LS, right? LS means this one. Okay, this one. So this is important formula, guys. You need to note down. And similarly, uh, we know J equal to uh, L plus J, right? L plus J. So from here, L value is going to be J minus S. So from here, L square value is going to be J square plus S square, right? L square, J square plus S square minus 2 JS, right? Minus 2 J dot S, right? This value. So this from here, the value is going to be this L square equal to J square plus S square minus 2 JS 2 JS cos theta, or cos theta will like 2 JS cos J dot S, right? This mod. Okay, so cos j dot s, this value is going to be j square plus s square minus l square upon 2 j into mod s, right? So this value is going to be cos j plus s. This value is going to be this one, j into j plus 1 plus s into s plus 1 minus l into l plus 1 upon 2 j into j plus 1 s into s plus 1. Okay, so this is also, and this is root, guys. Okay, this is also important formula, guys. Okay, so you need to note down. Okay, next is a question I'm going to solve. Question is the angle between L and S for a d electron in one electron system, one electron atom. Angle between LS we need to find for a d electron in one electron system. Okay, so we have d electron means L equal to 2 and S equal to half. So d electron, right? And we'll find j values are going to be, L plus S mod S plus L plus S2 mod L minus S, right? So j value is going to be 5 by 2 comma 3 by 2, right? So we can write this cos value, cos that angle between LS, right? Call S L dot S angle between LS, right? This is going to be formula j into j plus 1 minus L into L plus 1 minus S into S plus 1 upon 2 root L into L plus 1 and root S into S plus 1. Okay, so we'll simplify it, very simple. We'll put the value 5 by 2. Two values are there, so 5 by 2 and 1. 5 by 2 into 5 by 2 plus 1 is minus 2 into 2 plus 1 minus half into 1 plus half upon 2 into root 2 into 2 plus 1 into root 1 by 2 into 1 by 2 plus 1. Okay, simple calculation. So you can calculate, and this value is going to be 2 upon root 18 cos L dot S. Okay, 2 upon root 18. 2 upon root 18 2 upon root 18, right? So now, so this value is 0.4714. So from here, angle theta 1 is going to be 61.87. Okay, now we'll find cos L dot S for j equal to 3 by 2. So again, we'll put the formula. So I'm writing directly. So this is going to be 3 by 2 into 3 by 2 plus 1 minus 2 into 2 plus 1 minus half into half plus 1. Okay, this formula we have, this one, j into j upon 2 into root 2 plus 2 into 2 plus 1 into root half into half plus 1, half into half plus 1. Okay, so this formula, so from here cos L dot S, this value is going to be, we'll solve this, and this value is going to be minus 3 upon root 18, and this value is minus 0.701. So from here theta 2 value is going to be 135 degree. 135 degree. Okay, this is the answer, guys. So there are two values. So angle between this is 2. Okay, for j equal to 5 by 2, the angle is 61.87 degree, and for j equal to 3 by 2, the angle is theta 2 is 135. Okay, well, this is the one. Okay. Okay, guys, so I'm going to stop here, and remaining part I'll do in next class. Also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also, guys, please share my details with your friends, so that your friends can also watch my free live lectures, and all my detailed courses which I have completed, just going in my playlist. Okay, and will be benefited from it. Okay, guys, so remaining I'm going to do in next class. Thank you so much, guys. Bye now.